All right, so section 8 notes in chapter 8. We have two essential questions. First one is, how do you solve a rational equation? The second one, why is it important to check for extraneous solutions? At any time you need to pause, go ahead and pause it so you can write down whatever you need to write down. So, how to solve a rational equation? First, we find the LCD of all the fractions in the equation. Second, multiply every term in the equation by the LCD, so distribute it to every single term. If you picked your LCD correctly, then all of the denominators will cancel, and then you'll have no more fractions. So then you'll combine like terms, and then just use Algebra 1 skills to solve for the variable. 6, you do want to plug it back in to check for extraneous solutions, so we'll talk about that. I won't require that you show the work for that as a point. But you should really do that to make sure that your answers are correct. All right, so let's do example 1. Now, example 1 has two equations set equal to each other. That's what we call a proportion. And you don't have to do the steps that I just talked about to solve a proportion. You learned in Algebra 1 to solve a proportion, you cross multiply. So then I would do this diagonal. So that would be 3 times 4x plus 5. And that's going to equal the other diagonal multiplied, so that's 9 times x plus 1. So when there's that addition sign or subtraction signs, remember those are wrapped in parentheses. Okay, now we just do Algebra 1 skills. So solve, distribute. Okay, then we're going to, I'm going to subtract 9x. So then I get 3x plus 15 equals 9. Then I will subtract 15. So 3x equals negative 6. Divide by 3. So my possible answer is that x equals negative 2. Okay, so now I'm going to check, and like I said, you don't have to formally check every time, but you should, because you really do have to check and make sure that the denominator will never be 0. So I'm going to plug in 3 over negative plus 1, and we need that to be equal to 9 over 4 times negative 3 plus 5. So I get 3 over negative 1, which would be negative 3, and you could just type this in your calculator and it'll work it out for you. And then this will be negative 12 plus 5. Right, so then that would be negative 9. No, I can't think. That would give me negative 3. Oh, I'm sorry, I'm plugging in negative 2. That's why I was looking at this strange. It should be times negative 2 minus 5. There we go. That's why it's 9 over negative 3, which would be negative 3. So checks. Now, if you feel confident that this is the right answer, then really you just need to plug it back into the denominators here and make sure that when you plug it into the denominators, it's not equal to 0. And neither of our denominators were 0, so that's also going to check. So at the very least, you need to check the denominators if you don't plug it all the way back in like I did to make sure it works. That was plus 5. Goodness. Okay. All right, part B. So again, multiply on the diagonals. So 3 times 2 is 6, and that equals the other diagonal multiplied. So x minus 2 times x plus 3. So remember that means you have to FOIL. So I get x squared plus 3x minus 2x minus 6. Combine like terms, plus x minus 6 Then since you have a quadratic here, we do need to make this equal to 0. That'll be my 0. Now this is one where we can factor it. So what multiplies to give you negative 12 and adds to give you 4? That should be plus 4 and x minus 3. So then when you set each of those equal to 0 and solve, I would subtract 4, so x would be negative 4. I would add 3, so x equals 3. So those are my possibles. So then when you check, so this time, let's say I'm pretty confident these are the right answers, but I do need to make sure I don't have extraneous solutions. So I'm going to plug in negative 4 just into the denominator, because the denominator is what we care about. And if I put negative 4 minus 2, that's negative 6, which is not 0, so I keep negative 4. Don't care about the top, only the bottom, because remember we cannot have 0 in the bottom of a fraction. So if I plug in 3, 3 minus 2 is 1, so I'm still okay. So both answers are your answers. Okay. So like I said, you don't have to formally show the check, and I was just showing you that the denominator won't be 0 when you plug in either of these answers. Okay, so two fractions set equal to each other and nothing else on each side, then that's cross multiplication to solve that proportion. All right, example 2 is different. So notice we have two fractions on one side of the equation and a fraction on the other side. So we can't cross multiply to solve. So this is where you do the steps. So step 1 is to find the LCD. We look at 4 and the x's. So your LCD is 4x. All right, so let me rewrite this. Okay, so I am going to multiply every single term by 4x, and remember that is 4x over 1. So then on the diagonals, remember we can cancel. So with this fraction and this fraction, the x cancels, and that leaves us with 4 times 5, which is 20. So I'm going to get rid of those crossouts so I can do the next one. But that canceled out so that there is 4 times 5, which is 20. Oops, that should be a plus sign. Then bring down that plus sign. Okay, now when I do the 7/4 times 4x, the 4's cancel diagonally, and I'm left with 7 and x. So you write 7x. Bring down your equal sign. Now, so negative 9x times 4x, the x cancels. So you're left with 4 times negative 9. They're both on top of the fraction, so you multiply those across. So then that would be equals negative 36. Okay, so all of the denominators ended up canceling with some part of this LCD every time you multiplied it. So now we're left with this. Okay. All right, so now it's an easy equation. This is an easy algebra 1 equation. So now solve. So we would minus 20. So 7x equals negative 56. Divide by 7. X equals negative 8. So then when you plug it back in here to the denominators where the x is, negative 8 here is not going to make this fraction the bottom of the fraction 0. Now, you can check the whole thing if you're not super confident if you did it right. You can check. So 5 over negative 8 plus 7/4 equals negative 9 over negative 8. So then I would have to change this. So I get negative 5/8 plus 14/8 equals, and then that would be positive 9/8. And that checks because -5 plus 14 is 9, and then you keep this 8. So it works out. So x equals -8 is your answer. Okay, go ahead and pause and try part B. See if you can do part B. All right, so your LCD should have been 5x. Multiply everything by 5x. And remember, if you made that a fraction, it's over 1, so that diagonally things cancel. Okay, so first, this with 15 over x, the x's cancel. So we're left with 5 times 15, which is 75. All right, then you got to keep that 5x, but you can't just, once you cancel it with something in the first fraction, you still have to keep both the 5 and the x when you multiply the next fraction. So this time the 5 cancels with the 5. So you have an x times 4 left, so that's 4x. Then, like I said, you still have 5x here. And then this time, diagonally, the x goes with the x, and you're left with 5 times 7, so that equals 35. All right, now this is an easy equation to solve. So subtract 75, 4x equals -40. Divide by 4, x equals -10. Okay, so I can plug it back in and check. So I could do 15 over -10 plus 4 over 5 equals 7 over -10. Okay, well then I need to change this times 2 to make it 10 denominator. So it's 8/10. This stays the same, and it's -15 over 10. And this I could make -7/10, just put the negative in front. And that is, if you do -15 plus 8, you get -7, and you keep the 10, so it checks. So x equals -10 is your answer. Okay, so that's what you do when you have variables, and if this was x squared, then it would have been 4x squared, because remember, when you're looking at the variables, you take the highest exponent on the variable. All right, last type of problem looks like example 3, part A. We rewrite it, so 1 minus 8 over x minus 5. And if your denominators look a little complicated, like the second one does here on part B, then make sure you factor, because then that'll just make it easier when you're doing LCD. So what do you think my LCD should be on this one? We have an x minus 5 in the denominator and an x in the denominator. It should be x times x minus 5. All right, well, let's multiply by that. Well, this is just 1, so you have to do 1 times that because nothing will cancel, and you do have to think of it as over 1. So then that just leaves x times x minus 5. I'll distribute it in a minute. Minus, then here on the diagonal with this and 8 over x minus 5, the x minus 5s cancel. So then you're left with 8 times x. And we still have all of our LCD here, so let me replace it. And then on this one, the x goes with the x, so then you're left with the 3 times x minus 5. So again, if you pick your LCD correctly, then all of the denominators, all of the fractions should cancel, and you get an easier equation. Okay, now let's clean this up. So distribute on both sides, get this. Now let's combine like terms. So then I get x squared minus 13x equals 3x minus 15. Now you see you have a quadratic, so you have to get 0 on one side. So I'm going to move 3x over, so subtract 3x. And I'm going to move the 15 over, so I would have to add 15 because you always do the opposite. That'll go at the end. So then we get x squared minus 16x plus 15 equals 0. This is factorable. Now, if it's not factorable, then you'll have to use quadratic formula, but this one is factorable. X minus 15, x minus 1. If I set both of those equal to 0 and solve for x, so add 15, so x equals 15. Add 1, so x equals 1 are possible answers. So this time I'm pretty confident that these are right, so I'm just going to check if I plug 15 in here. 15 minus 5 is 10, so I'm okay. And 15, so no zeros in the denominator, so I keep 15. If I plug 1 in, 1 minus 5 is negative 4, I'm good. Plug in 1 there, I'm good. So both answers stick around. They're both correct. Okay. Okay, so on the next one here, we've got 6 over x minus 3. We can factor this x squared minus 9. Remember, that's difference of squares, so x minus 3, x plus 3. You always want to factor before you try and do your LCD. And that's helpful because x minus 3 shows up in a couple of them, and x plus 3 shows up in a couple of the fractions, so we're going to use one of each. All right, so we take this whole thing and we're going to multiply it by the x minus 3 times x plus 3, and keep in mind this is over 1, so that diagonally things will cancel. Okay, so this times the first one, the x minus 3 cancels, so I'm left with 6 times that parenthesis, x plus 3. Bring down your equal sign. Okay. And I'm just erasing this because this is still present. You still have to have this for the next fraction. All right, so then with this fraction and this fraction, both cancel. So then I'm just left with 8x squared. Then bring down your minus sign. All right, and then this comes back. And this time, diagonally, the x plus 3 goes away with x plus 3. So then you're left with negative 4x, so minus 4x, times this x minus 3. So we did a good job picking our LCD because all of the denominators of the fractions are gone, so now it's an easier problem. Okay, so distribute. And distribute on this side as well, so negative 4x squared plus 12x. All right, combine like terms on this side. So we get 4x squared plus 12x. And we still have 6x plus 18 over here. You have a quadratic, so we need to make this equal to 0. So I'm going to minus 6 and minus 18 over. Always opposite to get it on the other side of the equation. So then that'll be positive 6x and minus 18. Now, hopefully you notice I can divide by 2, and you can divide everything by 2. So when you're solving an equation, instead of putting 2 in front of parentheses and then factoring, see what you have, when it's an equation, you can divide everything by the number that you want to divide out. So that's still 0. 2x squared plus 3x minus 9. All right, this one, let's try to factor. So 2 times negative 9 is negative 18, and we want it to add to 3. So then we could use 6 times 3, and the 3 would be negative. Now you can't just write x plus 6 and x minus 3 because you have a 2 in front. So then what I'd normally do to do the AC method, I put the 2x squared. Remember, you rewrite the first one, then write these in the middle, plus 6x minus 3x, and then the end was minus 9. Divide by 2x, and I can divide this by negative 3. You always take the sign of the leading one. And so 2x minus 3 is one of my parentheses. So whatever you divide out here is one of your parentheses. And then when I write what's left over, 2x goes into 2x squared once and leaves an x. 2 goes into the 6 3 times, so plus 3, and then the x cancels. So there's your two parentheses. So we set each parenthesis equal to 0. Get our possible answers. So here, I would add the 3. So 2x equals 3, and then you would have to divide by 2. So one of my answers is 3 over 2, or 3 halves. Here, we would just minus the 3, so x would equal negative 3. That's your other possible answer. Now we do need to come back up here. If you go back to the original and plug in 2/3, or 3 halves, I'm sorry, when you plug in 3 halves, which is 1.5, if I did 1.5 minus 3, that will not give me 0 in the denominator, so I keep 3 halves. If I plug in 3, so our other solution was negative 3. If I plug in negative 3 here, I'm okay, but if I plug in negative 3 here or here, I get 0. Negative 3 plus 3 is 0, and you cannot have a 0 in the denominator, so negative 3 is out. The only solution is x equals 3 halves. So negative 3 is what we call an extraneous solution, because when you solved, you got it as an answer, but when you plug it back in to check, it makes the denominator 0 on one, just one denominator cancels it out. If it makes the denominator 0 when you plug it in. Okay. Now, if when you plug in both of these choices, and let's say both of them didn't work, so we had to cross out 3 halves and negative 3, well, then you would say no solution, because you already solved and got the 2 possible solutions and neither of them worked. So if nothing worked, then it's no solution. Okay. All right, so go ahead and pause it and try the exit slip and see how you do, and then we'll go through it. All right, so to start here, you should have had your LCD as the 2x and then the x plus 1. Even though 2x showed up twice, you're not going to make that 4x squared. Don't multiply it, because then it won't be the least common denominator, and you'll have more variables and things to deal with. Okay? All right, so let's multiply. So 2x times x plus 1. So when you do the 3x over x plus 1 with the LCD, the x plus 1's cancel, and you're left with 3x times the 2x, which I'll do in just a second, but it is multiplied. Okay. Then remember, you still have the x plus 1. Just because I canceled it in the first one doesn't mean it went away. Okay. Then minus, I've got the 2x goes with the 2x. So then I have a minus 5 left, which counts as a negative 5 times this parenthesis x plus 1. Bring down your equal sign. So the 2x comes back. So you can multiply by the full LCD. And then this time the 2x goes with the 2x. So then I'm left with the 3 and the parenthesis x plus 1. Okay, much easier when there's no fractions. So now I just multiply this, which is 6x squared. Distribute negative 5, so minus 5x minus 5. Distribute 3, so 3x plus 3. Okay, we have an x squared, so then you need to make a 0 on one side, so we'll minus 3x minus 3. Okay, so then that should be 6x squared minus 8x minus 8 equals 0. Okay, so again, we could divide everything by 2. So then that gives me 3x squared minus 4x minus 4 equals 0 still. Okay, let's try and factor. So 3 times negative 4 is negative 12, and we want to add negative 4. So hopefully then you use 6 and 2, and 6 would be negative since we want negative 4. So then I'm going to write 3x squared, and in the middle, we write minus 6x plus 2x, and then write the end, which is minus 4. Then see what you can pull out. So here I can pull out a 3x. Here I can pull out a 2. So that means 3x plus 2 is one of my parentheses. The other one is what's left over. So when I divide 2 into that, I just get x. Negative 4 divided by 2 is negative 2. So x minus 2 is my other parenthesis. So then you have to set each parenthesis equal to 0 and solve. So here we would minus 2 first. Then we would divide by 3. So negative 2/3 is one of our possibles. And then here we would add 2. So x equals 2 is our other possible. All right, well, when I go back to the original, if I plug in negative 2/3, that will not make this 0. What would make this 0 is if x was negative 1 or x was 0. Those are our restrictions if you look here. And neither of my answers are negative 1 or 0. So then they both stay. Okay, so if you want to think of it that way, when you think of what's my restrictions for all the denominators, if one of your answers is a restriction on the denominators, then you would cross that answer out. But both of these work out, so we're good. So negative 2/3 and 2 are your two answers for this problem. Okay. All right, so those were the notes for section 8. If you still need additional help before the test, make sure you come in and see me and get that